There are three special types of triangles that we will look at here. Firstly, the scalene triangle. All three sides are different in length and all three angles are different. In the isosceles triangle, we get two sides being equal and the two angles opposite the equal sides are equal. In an equilateral triangle, all sides and all angles are equal. Each of the angles is equal to 60 degrees. A right angle triangle is a special triangle where one angle is equal to 90 degrees. In an acute angle triangle, all angles are acute. In an obtuse angle triangle, one angle is obtuse. Now guys, some of the other important theorems that we need to remember when dealing with triangles is as follows. The one important thing is we all know, hopefully we all know, that the sum of the angles of a triangle equal to 180 degrees. So therefore, if you add all of the angles up in any triangle, doesn't matter if it's obtuse, scalene, acute angled, right angle, whatever type of triangle, the angles are always going to add up to 180 degrees. And then another important theorem that we use over and over again is the exterior angle of a triangle. So if I draw a triangle as follows, we'll call this triangle A, B, C, and we'll call it C1 and C2. Now, what the exterior angle of a triangle says is that the exterior angle of the triangle will be equal to the sum of the interior opposite angles. So what that would mean in terms of this diagram, the exterior angle, so that would be angle C2, it's on the outside of triangle ABC. That angle is going to be equal to the sum of the interior opposite angles. Therefore, C2, angle C2, would be equal to that angle A plus this angle B. That's an important theorem that you will use over and over again when you deal with triangles. So the exterior angle is equal to, so in this case C2 is equal to the sum of A plus the sum plus angle B. Another important theorem that you did in grade 9 is the theorem of Pythagoras. Remember, for the theorem of Pythagoras to exist, you need to have a 90-degree triangle, so a right angle triangle. So if that angle is 90 degrees, and if we call this A, B, C, then the theorem of Pythagoras says AB squared, so the hypotenuse squared, is equal to CB squared plus AC squared. So therefore, the hypotenuse squared is equal to the sum of the two shorter sides when you are dealing with a right angle triangle. So that's another concept. You will see this coming up again in trigonometry. We are told that in the diagram below, triangle ABC is drawn, and they give you the coordinates of each of the vertices. They say use analytical methods to determine the values of P, and they give you two different scenarios. Now, the concept of analytical geometry you will come across again in lesson 11. So let's do the first part. They say use analytical methods to determine the value of P if triangle ABC is right angled at C. Right angled at C, that would mean that on the drawing, the angle at that point would be 90 degrees. Now, since we're using analytical methods, the one way we could do this is we should realize that if this angle C is 90 degrees, it would mean that AC, the line AC, is perpendicular to the line BC. Now that is something we will come across again in analytical geometry, so you can revise that concept there. So when you have a right angle triangle, the two lines forming that right angle will be perpendicular to each other. What you will also remember is that the gradient, or rather the product of the gradients of perpendicular lines is equal to -1. So therefore, in this case, the gradient of AC, the product we said, so multiplied by the gradient of BC, that would give us an answer of -1. And we're going to use that to help us to work out the value of P. All right, so first to work out the gradient of AC, we're going to use the formula y2 minus y1 all over x2 minus x1. Again, this is a formula you will see again when you do analytical geometry. So in this case, if we go to our diagram, if I call A the point x1, y1, then C would be x2, y2. So in order to find the gradient from A to C, I can say 0 minus P, so y2 minus y1, all over, and just make sure you take this in the right order. So because I've started at point C, I have to take the x value now in the denominator from point C. So it's going to be -2 minus 0. And that would give us the gradient of AC. So my answer here is going to be minus P over -2. So this is really P over 2, or a half P. Now what we need to do in order to use the fact that these lines are perpendicular is we need to work out the gradient of BC. So B has coordinates 3 and -8. So I work out the gradients of BC, and it's going to be 0 minus -8. So just use brackets here so that you remember to change your sign, all over -2 minus 3. So if we go back to the diagram, we went 0 minus -8 and then -2 minus 3. This is going to give us an answer of 8 over -5. So that's the gradient of BC. Now since BC is perpendicular to AC, and we know that the gradient of AC times the gradient of BC is equal to -1, what that implies is that the gradient of AC, which is P over 2, would be equal to the negative inverse of the gradient of BC. So what I'm saying here, if I have to get an answer, so for example, if my gradient was 2, and I know that gradient times another gradient must give me an answer of -1, then the other gradient would have to be the inverse of the 2, so this is 2 over 1. Inverted, it would become 1 over 2, and we would change the sign. 2 is positive, so this would become -1/2. And 2 times -1/2 will give me -1. So that's the concept we use. Once you have the one gradient, in order to get an answer of -1, the other gradient would be the negative inverse of the gradient you have. So we know that this gradient BC is -8 over 5. Therefore, the gradient of AC is going to be the negative inverse. So we swap 8 over 5, it becomes 5 over 8. And this is already negative, so if I multiply it by negative, my answer here would be positive. But we know that the gradient of AC is also equal to P over 2. So therefore, this means that P over 2 must be equal to 5 over 8. And now we can just solve for P. So I can multiply the 2 over out of the denominator, multiply both sides by 2 to get rid of it in the denominator. So we end up with 10 over 8, which we can simplify. 2 goes into 10 5 times, 2 goes into 8 4 times. We can simplify P to 5 over 4. So that's the one way that we can find the value of P, by using the fact that since C is a 90-degree angle, that means that the gradients of the two lines, the product of the gradients, is going to be -1. The other way you can do it, and this is shown in your workbook, is by using the theorem of Pythagoras. We're not going to do both ways because it's self-explanatory, and if you use the theorem of Pythagoras between the lines, let's just, on this diagram, I'll just show you how to do it, but as I say, you'll get to the same answer. This is our 90-degree angle. Therefore, the side opposite that, AB, would be the hypotenuse. So therefore, by Pythagoras, we can say that AB squared is equal to BC squared plus AC squared. So you can use lengths and the distance formula to help you to work out the value of P. But as I said, either way, you will get to an answer of P is equal to 5/4.